In this example, we want to calculate the odds ratio and a 95% confidence interval. And particularly, we want to see whether there is an association between, say, cancer and a certain mutation. So what we can do is we can do a study and we can see how often do we find that a patient develops cancer if they have the mutation and develop cancer without the mutation. So we can do a patient study here, and we can set up what is called a 2x2 matrix here. And what we can do is we can calculate the odds for having cancer if you have the mutation, and the odds for getting cancer if you don't have the mutation. So in the first case, so the odds cancer with mutation, we would just simply say, okay, if you've got the mutation, the odds would be 147 over 129. So these are the people with the mutation. The odds of having cancer no mutation would then be the other column, so it would be 200 over 121, and we now can calculate the odds ratio for that just simply by dividing the two odds. So 147 over 129 divided by 200 over 121. And we know that we can divide two fractions by standing on the head and giving it a kiss. This is how my daughter phrased it. So this would be 147 over 129. And we stand this one here on the head. So 121 over 200. And give it a kiss. And if we do this, we would get something along the line of 0.689. So that's our odds ratio. And we see the odds ratio is smaller than 1. And this should make us think later on, what does this actually mean? So, however, we want to check out what the confidence interval is, and therefore, in order to do that, we would take the log of the odds ratio, so we would calculate ln of the odds ratio, and that would be ln of 0.689, and this gives us a value of negative 0.37. So this is the logarithm of the odds ratio. Now we can calculate the confidence interval for this ln of the odds ratio, and we would do that by doing the following calculation. So we have ln of our odds ratio plus minus 1.96 times the standard error for our log odds ratio, and I indicate this by ln OR here. So that's the standard error of the log odds ratio. How do we get this? Well, there is this what is called the Wald method, and this standard error of the ln for the odds ratio is the square root of the individual numbers, of the inverse of the individual numbers. So it would be 1 over 147 plus 1 over 129 plus 1 over 200 plus 1 over 121. And when we put these numbers here into a calculator, we would get the square root of 0.028, and this gives us 0.167. So now we've got our standard error of the ln odds ratio, and we need to multiply that by 1.96. So we would get negative 0.37. That was our log odds ratio, plus minus, this one gives us 0.33. So what we can do is we can calculate the upper and the lower bound for our ln odds ratio. So the lower bound, or the lower margin for the ln odds ratio, that would be negative 0.37 minus 0.33, and that gives us negative 0.7. And the upper bound, that gives us, that would be negative 0.37 plus 0.33, and that gives us negative 0.04. So these are the two boundaries. And how do we need to imagine that? So here we've got our ln odds ratio, so that here would be negative 0.37. That's the ln of the odds ratio. Here we have negative 0.04, and here we've got negative 0.7, and we are pretty sure that 95% of all the ln odds ratios that we could calculate for the number of cancer and mutations are in this range here. So they are in this range here. What we also notice is that 0 is not part. 0 would be probably somewhere here. 0 is not part of this confidence interval. But what does an odds ratio, an ln odds ratio of 0 mean? Well, we can say ln odds ratio, if the ln odds ratio is 0, we can convert that into the odds ratio, which is simply e both sides. Then we've got the odds ratio equals e to the power of 0, and that would be 1. What does an odds ratio of 1 actually mean? An odds ratio of 1 means that there is no association between cancer and mutation. It does not matter if the odds ratio is 1. It does not matter whether somebody has the mutation or not when it comes to the onset of cancer. But our odds ratio does not, and the confidence interval for the ln odds ratio does not include this case, so we can say there is actually an association. But let's look at that in a little bit more detail. So we can convert our two upper and lower bounds for the ln odds ratio into the bounds for the odds ratio, just simply by calculating. So the upper bound for the odds ratio would be e to the power of negative 0.04, and for the lower bound for the odds ratio, again, it would be e to the power of negative 0.7. And if we put that in a calculator, we would get for this one here 0.96. And here for this one we get 0.5. So our odds ratio, we know that the odds ratio, our bounds for the odds ratio are somewhere between 0.5 and 0.96. And again, we see 1 where it doesn't have any effect is not included in this 95% confidence interval. And that indicates that there is an association. And what it also shows is that getting cancer when you have the mutation, so getting cancer if you have mutation is less likely than getting cancer without the mutation. And we saw that because the numbers for cancer with and without mutation are, or the numbers for getting cancer with mutation are higher than I got it the wrong way around, getting cancer with the mutation, the numbers are smaller, the odds are smaller than getting cancer without the mutation. So in this case, we could even say that the mutation might have a protective function. Protective function. So whatever this function is, and obviously we would need to do more research with that, but that's quite an interesting result, and I hope this actually makes sense how you calculate these things.